Number 7, it says, which of the following cannot be considered a single phase? And the correct answer is D, a heterogeneous mixture, because a phase is same properties, same structure. Everything's similar. Homogeneous has a single phase, but heterogeneous has multiple phases. Number 11 says the chemical formula of a compound does not indicate, and then gives you several options, and B is the correct option, how elements are joined in the compound, i.e. whether it's covalent or ionic. You sort of do know that, because you know whether it is a metal to non-metal or two non-metals. If it's metal to non-metal, you know they're joined ionically. If it's non-metal to non-metal, then you know it is joined covalently. All right, so 18, express the sum of 7.68 meters and 5.0 meters using the correct number of significant digits. The answer would be 12.7 meters. The rule, if you look in your R60 reference in your book, it says that the sum is always based on the least number of significant figures. In the case of 5.0, it is only one digit below 0, so you can only have 12.7, not 12.78 or whatever it would have been otherwise. 24, if the temperature of a piece of steel decreases, what happens to its density? And of course the density increases. Now why is that? Here we go. Here I'm a little iron and I'm solid, and I cool myself down so the jiggling stops and the particles get closer together because they're not colliding as often and bouncing. And what happens? So you get a smaller volume. It contracts. Your volume becomes less. Yeah, just a little bit. But you have that same amount of mass in the smaller volume, and you have a greater, say, density.
Density.
All right, good. 38. What is the next atomic orbital in the series of 1s, 2s, 2p, 3s, 3p, and of course it is 4s. You can review that on page 133, and has a lower energy level than you would if you had a 3D. That's what it's trying to get to. The next one is electrons are in sulfur, in a sulfur atom, and the answer was 2. We have to use Hund's rule there and just line them up. You're going to get down into the 3 P's, and you're going to go 1 in each, so that'd be 3 across, and then you're going to double back and you're going to only have 1 left because you only got 4 p orbital electrons, and that leaves you with 2 unpaired. Hope that makes sense to you. If it doesn't, ask me about it. I'll explain it. Okay. 55. What is electron configuration of gallium? And it would be 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d10. Now this is one of the exceptions to those rules we have, because if you get 3d10, you are filling that entire sublevel, which is more stable than leaving it partially filled. So you jump right over the 4s2 and you go to filling the 3d10. Hope that makes sense to you. Then 57, how many electrons does silver have to give up in order to achieve a pseudo noble gas electron configuration? Well, pseudo noble gas, that means like a noble gas, and that means you're going to have 8 electrons in the outer energy level, and silver has 47 electrons, and if you run it all the way out, you find that it's going to end up in the d orbitals, and it's going to end up with 8. If it gives up 1, it will have 8 electrons in the d orbitals and be a pseudo, that's its outer energy level, and be a pseudo noble gas. And the same way with copper right above it, the next question down, which of the following ions has a pseudo electron configuration? Well, it's copper at a 1 plus, because it is doing the same sort of thing. It is dropping 1 and getting to 8 valence. So the next one is 62, and it says, which metallic crystal structure has a coordination number of 8? Well, you got to know coordination number is the number of oppositely charged ions that surround a particular ion. And then you have to know that a body-centered cubic has 1 ion sitting in the center and a cube all around it. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that's on page 202 in your book. Okay.